Okay, here we go. The second type of conic section, as I said, is the ellipse. It looks like what we typically call an oval, or like when you were a little kid, that's what you learned this shape will look like. However, by true definition, we say that it is a curved shape where the sum of the distances from 2 points called foci to every point on the ellipse is equal. Technically, if you look up the phonics, bless you, I think that was a sneeze. If you look up the phonics for the saying, technically it's called foci. I have just learned it my whole life as foci and haven't really gotten out the habit, so you can call it either. What do you know? So these tiny points right here, F1 and F2, those are the foci that we're talking about. We know that the radius of a circle is that equal distant from the center point to every point on the circle. What can you tell me about the radius or any of the radii on an ellipse? Or can you define for me what part of the circle is a radius? Half of the diameter, okay. Which is where? Like where is a radius located or what does it connect? If you said something, repeat it because it didn't come through.
The radius is a point on the perimeter of the circle to the center of the circle.
Good, Zach. Okay, so if we keep that definition in mind, right, it goes on the circle to the center of the circle. If we kind of compare that definition to that of an ellipse, what can you say about quote unquote radii, and I'm hesitant to use that term, for an ellipse? If it starts at the center point and then it goes to a point on the circle or on the ellipse.
Have a different distance.
So they have different distance. This vertical, what seems to be a radius, is a lot shorter than this horizontal one. And then among the first quadrants, there are all of these infinite distances in between. So we don't really use the term radius with an ellipse because that's confusing. Instead, we'll have some other words that we're going to use. What I do want to do, though, is show you by definition what I'm talking about in terms of how an ellipse is formed. So we can take a circle by using a compass, setting a fixed distance, plot a pivot point, and then move around in a circular motion, and bam, you have your circle. For an ellipse, it would be if we pick a point on the circle, and if we draw a segment that connects that point to each foci. So let's call these distances C and D. By definition, what this is claiming is that if we added those two segments together, C plus D, then they would equal any other sum of distances from a point on the ellipse to the foci. So then if I pick this point down here and connect it to each of the foci, maybe let's call those E and F, that those things would be equal. So C plus D would equal E plus F. And that goes for any point that's on the ellipse ever. They will always be, the sum of the distances will always be equal to the foci. Okay, standard equation of an ellipse starts off like a circle. So it has x minus h squared plus y minus k squared. So this part is the same. What is the equation of a circle equal to?
Any answers? No answers. What's one here?
Okay. Y'all know it though. You did it yesterday. What's the equation of a circle equal to? Yeah, r squared, right? Well, because we just discussed that for a radius and an ellipse, it's not really consistent, then we're not going to use r. One of the key differences between an ellipse and a circle is that an ellipse is always equal to the number 1. And what makes it very different is that our x minus h squared binomial will be over a squared, and then y minus k squared will be over b squared. This is the standard form of an ellipse. So that's the big takeaway from today. Does that look familiar from Algebra 2? Hopefully. Okay, similarly to a circle, HK stands for the center point. The equation of an ellipse is always equal to 1, as I just said. And then the other key elements are A and B. Okay, A and B stand for half the lengths of the major and minor axes. And major and minor axes are exactly what they sound like. Major one is the big one, the minor one is the smaller one. They are also called the horizontal and vertical axes. Horizontal and vertical axes, depending on whether or not they are under the x or the y variable. Okay. Lastly, one of the most important pieces is that the bigger denominator, so a squared or b squared, should always be written first, and it's always going to be a that is first. So whatever number is bigger is first, and you'll see the difference in the two. So as you could probably guess, we could have different orientations of an ellipse, and it doesn't even have to be limited to horizontal and vertical. You can have an ellipse that looks something like this, but we're going to be dealing with just one of these two orientations. If we have a horizontal orientation, that means we are stretched more on the horizontal axis. So that means the x squared term will be first in the standard equation of a horizontal ellipse. If we have an ellipse that has a vertical orientation, then that must mean that the y squared term will be first. So this standard equation formula is subject to change the order of the x and the y. Those two can swap places. And they should swap places depending on the direction of your ellipse. Okay, for the horizontal orientation or the vertical orientation, no matter what, if I ask you to find the major axis vertices, they are kind of what it sounds like. So if we say that our major axis is always going to be the bigger one, then the endpoints of the major axis are called vertices. So wherever your bigger axis is, those endpoints, I'm going to put V here for vertices. And the vertical orientation ellipse has the same endpoints, except those are the topmost and bottommost points. Okay, visually they're easy to find on a coordinate plane. You can just figure out what their ordered pair is. Algebraically, what you're going to do is, if you take your center point HK in the horizontal direction, if we stretch, major axis is always our bigger number, which is always going to be dealing with A. Minor axis is the smaller number, which means it's going to be dealing with B. Then that means our major axis is found by doing, or the vertices are found by doing H plus or minus A, comma, K. And same thing with the vertical orientation, except since it's stretched more in the Y direction, then we're going to have H and then K plus or minus A. So the main difference is, where do you add the A? In the horizontal orientation, you add the A where the major part is stretched, in this case to the X. For the vertical orientation, you add the A to the part that's stretched more, which is the Y. On the other hand, we have what are called co-vertices. So I'm going to put CV for those. And those are just the endpoints of the minor axis. And no matter the orientation, it has them. It's just the two that are closer together. And as I said earlier, because the minor axis is smaller, then it deals with the variable b, and it's found by adding b to the x or the y term, just depending on which way it is being stretched. So for the minor axis co-vertices for a horizontal orientation, that's found by doing H and then K plus or minus B. Minor axis co-vertices for vertical will be H plus or minus B and then K. So I had someone kind of freak out on me earlier this morning, like, oh my gosh, do we have to memorize all those things? And the answer is kind of. I'm not going to say at this point whether or not I'm not going to give you any kind of assistance on your test, but I will say that there's kind of a pattern, and that you don't need to feel like you have to use flashcards to study them and memorize them. The idea is that you can figure them out. And here's what you need to recognize. Notice that all 4 of these coordinate points have H and K. So everything is based off of the center point of your ellipse. And then you're either adding or subtracting A or B depending on the direction. Again, major is the bigger direction, so major is always associated with A. Minor is always associated with B. So we'll practice that in a few minutes. Last thing to talk about before we do an example is that every ellipse has 2 foci. So total, there are 4 vertices. We call 2 of them just regular vertices, the other 2 co-vertices. The foci, though, there are only 2, and they go along the major axis. You will not find them on the minor axis. They go along the major axis at a distance of c units from the center point, where c squared is equal to a squared minus b squared, and as we said earlier, a has to be bigger. So a is greater than b, and they are both positive. So visually speaking, I want to draw on this ellipse where everything would appear. So A is your bigger axis distance, and I want to go back up here to what we said on one of these bullet points. A and B stand for half the lengths of the major and minor axes. So in this ellipse, the major axis runs left and right because it's bigger, and half of it is A. So it's kind of like a radius. Again, not really, but kind of. So I'm going to call that A. B is half the length of the minor axis, which in this one is vertical, so half of that is B. So we get it's kind of like a vertical radius, if you will. And then C, by definition of foci, is the distance from the center point to the focus. So the focus are these 2 points, so that is C. That's where A, B, and C come from visually. Now, algebraically, it's going to be better to find the foci because many times you're not going to, those don't always land on coordinate points. Again, foci start off of the center point, and then you add to or from there. So for the foci, C is added to major direction from center. C is added, and of course added is subtracted as well. So C is added or subtracted to the major direction from the center point. So if we have a horizontal ellipse like this one, then I'm going to have my center point HK, but H I'm going to add and subtract the distance of the focus C. And the same thing with the vertical, except I'm going to add it to the K, so it'll be H and then K plus or minus C. Again, I want you to notice both of them start off with the center point, HK, and add C either to the X or to the Y. So there's not a lot to memorize. You should be able to just derive these. Okay, does anyone have any questions about anything that we've defined so far before we do some examples? Okay, I'm going to interpret your silence as a no. Okay, for these first 3, the directions just say write the equation of each ellipse and then find its foci. Well, if you look back at the equation in standard form over here, in order to write that, I need a few different variables. I need H and K, which are the center points, and I need A and B. So let me write down what I need. Okay, in order to write the equation I need the center point HK, and I need A, and I need B. For the foci, if I look right above this at these two coordinate points, I need the center point and I need C, which we were already going to find the center point for the equation. So the new thing is that we just need C. So basically, we need HK and then A, B, and C. Okay, for number 1, where's the center of this ellipse? Origin, which has the coordinate 0, 0. Thanks for shouting, Zach. I appreciate it. Okay, so HK is 0, 0. Then you simply count your A and your B. So remember, A is kind of like the bigger axis, or the bigger radius. In this case, it's being stretched in the x direction. So if I count from there to the vertex, A is going to be 3. And then B is the shorter distance from the center to a point on the ellipse, which is 2. So A is 3, B is 2. That'll suffice for the equation, but in order to find the foci, I also need C. So then if I use this equation up here, where C squared is equal to A squared minus B squared, then we know that C squared is equal to 3 squared minus 2 squared, which is 9 minus 4, which is 5. So that means C is going to equal plus or minus the square root of 5. So that's all the information that we needed to find, and now we can write our equation and find the foci. Okay, so I'm following the template of the equation up there that I wrote in pink, x minus h squared. So for us, that's going to be x minus h is 0 squared over a squared, which a is 3 squared, plus y minus k is 0 squared over b squared is 2 squared, and every ellipse ever in the world is equal to 1. Now, a couple things. You need to check A, that your bigger number is written first, okay, which it is, right? We have 3 squared written first, so that one will be fine. A is written first. And you have to make sure that the orientation of your ellipse, that variable is written first. So since this one is horizontally stretched, then that means we want x squared term first, okay? And in plugging in your information to the formula, you also want to make sure you simplify it. So you don't even have to write this step. Honestly, you can go straight to the final answer. X minus 0 squared is not simplified because anything minus 0 is itself. So you need to leave your answer as x squared over 9 plus y squared over 4 is equal to 1. So there's the equation of the ellipse. For the foci, again, every time you write foci, you're going to start with the center point. So the center point here is just 0, 0. And then all you do is, from your center point, you're going to add or subtract C in the bigger direction. So which axis is bigger for us, the X or the Y? Okay, so if your X is the bigger one, then that means you're going to be adding and subtracting C from your X. So it'll be 0 plus or minus the square root of 5, comma 0. And then again, go ahead and always simplify if possible. 0 plus or minus square root of 5 can just be written as plus or minus square root of 5, 0. Now, I didn't ask you to, but you will be asked in the future, so we might as well practice actually graphing the foci. So what is the square root of 5 approximately as a decimal? 2 point something, right? So that means you're going to go up, or sorry, to the right 2.2-ish, and then don't go up or down at all, and then to the left 2.2-ish, and then don't go up or down at all. So foci typically are not going to be on a coordinate for whatever reason, depending on the other distances. Okay, number 2. The center of this ellipse is also at 0, 0. And then I need A, B, and C. Remember, A is your bigger distance. So this time your major axis, notice, is stretched vertically. So what is A?
5.
5, right? It's the distance from the center up 5. So A is 5. B is the other distance, which is 4. And then you can find C if you want, but notice the foci are actually already on the graph for us, so we don't actually need to solve for them. And then we just gotta plug our information into the standard equation. So x minus 0, again, you can even kind of skip that step and just know that anytime you have an ellipse centered at the origin, it's always going to start off like this. X squared plus y squared is equal to 1. And then our A term, well, okay, you can do this in a couple of different ways. If you know that your A term is always first, you can write that first. I kind of always pair my x's with the x stretch. So like I know my x in the x direction was stretched 4. So I'm going to put 4 squared. And in the y direction it was stretched 5, so I'm going to put 5 squared. But the issue is 2 things. I know this one is vertically stretched, which means y squared needs to be first. And I know my big term, A, always has to be first, which is why 25 needs to be the first denominator instead of 16. So I actually need to swap these two. So I'm going to have y squared over 25 plus x squared over 16 is equal to 1. And then they already give us the foci, but we can go ahead and write them as coordinates. One is at 0, 3, the other is at 0, negative 3. So we can say that the foci is going to be at 0 plus or minus 3 if we write it as one coordinate. Questions so far? Okay. Number 3, this one's going to be a little bit different. Where is the center of this ellipse? Okay. If you have a difficult time seeing that 0, 2, you can always connect the vertices and the covertices, and where they intersect is going to give us our center point. Okay, so our center point's at 0, 2. A is going to be our bigger radius stretch, if you will. In this case, it is horizontal. So we know our x squared term is going to be first for future reference. So A is going to be 4. B will be this distance vertically, which is 3. And then they don't give us the foci, so we can solve for that. We know that c squared is a squared minus b squared. So 4 squared minus 3 squared will be 16 minus 9, which is 7. So that implies that c will be plus or minus the square root of 7. Okay, for the equation, you're going to have x minus 8 squared. Well, h is already 0, so we can just leave that as x squared. I go through my x's and y's first, and then I go back and do the denominators. You can do it however you want. It's just a preference thing. And then I do y minus 2 squared equals 1. And then for my denominators, I just know that that's the direction that I'm stretching each way. So in the x direction, I've got 4. Again, that's my bigger number a, so 4 squared 16. And b is going to be 3 squared, which is 9. So there's the equation. And then the foci, again, we always start foci with the center point. Center point is 0, 2. Is our major axis the x or the y?
Yeah.
Is the x, that's how we know that we're going to be adding our foci to the x direction. So it'll be 0 plus or minus the square root of 7, comma 2, which can be simplified to just be plus or minus square root of 7, 2 as those foci coordinates. Any questions so far on the front? Is all this kind of familiar to y'all? Hopefully, a little bit at least. Okay, on the back side, the top two questions are similar to what we just did, except instead of giving you a graph, I'm giving you just some information about the ellipse, and you kind of have to gather the rest. Okay, so for number 4, I'm telling you where all the vertices are. So we're going to graph the endpoints first. So it says endpoints of major axis are at 2, 6, and 8, 6. I apologize, these are going to be a little bit off the graph, some of them. So go ahead and plot these for coordinate points. 2, 6, 8, 6, 5, 4, and 5, 8. And graph your ellipse first. And then our first question is finding, well, in order to write the equation, I have to know what the center is. Again, it's a little bit hard to tell, especially whenever we graph the ellipse, to tell whether where the center point is. So for these, I definitely like to connect my vertices. So if I do that, then where they intersect is our center point. So I know that HK is at, what is that, 5, 6? Which you could even do that algebraically if you notice the connection among the endpoints that they gave us. The major axis Y values are 6, and the minor axis X values are both 5. So if you put those together, that's where you get your center point from. Okay, so there's HK, and we need A, B, and C. A is your major axis total length divided by 2. Or think about it as a radius, which will be 3. And then our shorter length will be 2. So B is 2. And then we know C squared is equal to A squared minus B squared. So it'll be 3 squared minus 2 squared. So 9 minus 4 is 5. So then C is going to be plus or minus the square root of 5. So to write the equation, we'll have x minus h squared. That'll be x minus 5 squared plus y minus 6 squared is equal to 1. And then under the x term, I've got a squared, so that'll be 9. And then on the y term, I've got 2 squared, which will be 4. So there's the equation. And then again, the foci, we always start at the center point, which the center point is 5, 6. And the major axis is in the x direction, so I'm going to be adding C to the x value of the center point. So then the foci is going to be 5 plus or minus square root of 5, comma 6. Okay, if I've lost you so far, tune back into this next one because this is where a lot of people make very careless mistakes. Number 5 is worded a little bit differently. It says the major axis is 10 units long and horizontal. The minor axis is 2 units long, and the center point's at 0, 0. So the easiest part about this question is that the center point is at 0, 0. So we're going to start there. Now, when it says the major axis is 10 units long and horizontal slowness is going left to right, so it's being stretched more along the x-axis. When it says that it is 10 units long, that's talking about the total length of the axis. So in order to achieve that the total length horizontally is 10, it means we got to go to the left 5 and to the right 5. Okay, not to the left 10 and to the right 10. That would give us a total axis length of 20. And then if the minor axis is 2, then that means in order to achieve a total distance of 2, we're going to go up 1 and down 1. So this is going to be your lovely, skinny ellipse. Okay, we knew center already is HK is at 0, 0. A, our longer major axis length cut in half is 5. And then our minor axis length cut in half is 1. So then we write the equation of our ellipse. Again, any ellipse that's centered at the origin is going to just be x squared plus y squared equals 1. In the x direction, it's being stretched at 5, so 5 squared is 25. In the y direction, 1 squared is just 1, and anything divided by 1 is just itself. So we actually just don't even want to write it that way. As a simplified version, we want x squared over 25 plus y squared is equal to 1. Okay, and then lastly we have the foci, which again we're always going to start at the origin. Our bigger axis is the major axis is in the x direction. So, oh, we didn't find c yet, huh? Let me go do that. Okay, c squared is equal to a squared minus b squared. So that's going to be 25, well, I'll do 5 squared minus 1 squared. So 25 minus 1 is 24. So that means c is going to be plus or minus the square root of 24. What square number is a factor of 24? 4. How many times? Goes into it 6 times. And then 4 square roots of 6 can be reduced to plus or minus 2 square roots of 6. So that's our c value, plus or minus 2 square roots of 6. So that means the foci in the x direction will be plus or minus 2 square roots of 6, and then we don't go up or down in the y direction. Okay, I know it's after lunch and you guys are just kind of just quiet. I do see y'all working great, but do y'all have any questions of anything that needs to be clarified so far? Okay. These last 4 questions are backwards. Instead of asking you for the equation, I'm giving you the equation, and I'm asking you for the center, the foci, and the vertices, and then I want you to graph it based on that information. Okay, so for number 6, center point's pretty easy, except you have to just make sure you pay attention to the order of the variables. Even though the y squared term comes first, which off the bat tells us that we know this one's going to be stretched vertically, your h and your k are still paired with the x and the y, respectively. Okay, so your center point is going to be -2, +1. So let's graph that first. -2, +1. Okay, next is the vertices. I would actually graph it first and then get the vertices. So this 4 and this 1, remember 4 is always your a, whatever number's first is always your a squared. Whatever second is your b squared. So a is kind of like the radius. So if a squared is 4, then that means a must be 2 if we take the square root of both of them. But that number is under the y variable, which means in the y direction, I'm going to be stretching up 2 and down 2. And then if b squared is 1, then that must mean that b is equal to 1. And in the x direction, because it's under x, we're going to go 1 to the left and 1 to the right. With me so far? And even if it's not beautiful, go ahead and connect those points to make it look kind of like an ellipse. Okay, now you can name the vertices. Remember, the ones that we call just regular vertices are along the major axis. So that's going to be, in this case, because it's stretched vertically, it's going to be the topmost and bottommost points. So it's going to be -2, 3, and -2, -1. And then your co-vertices are going to be the ones that are closer together along the minor axis, which will be -3, 1, and -1, 1. So that's the second part. And then the last thing to find is the foci. Again, by graphing, we really have no idea where they are. So we need to find, using A's and B's and C's, we need to figure out where that is. So if we know that C squared is A squared minus B squared, y'all, A squared and B squared are given in the equation. So if I just use those numbers for A squared minus B squared, that'll be 4 minus 1, which is 3. Then that implies that C is equal to plus or minus the square root of 3. So that means our foci in the y direction means I'm going to be adding square root of 3 and subtracting square root of 3 from my k variable. So the foci, I'm going to start at the center, -2, and then 1 plus or minus the square root of 3. Okay, number 7 is very similar, except the x and the y are back in, I'll say, typical position. X is first, y is second. So that means this one's going to be stretched horizontally. Your center point, HK, is going to be 3, -3. A squared always comes first, so A squared is 16. B squared is 9. So since 16 is under x, the square root of 16 is 4, that means in the x direction, we need to go to the left 4 and to the right 4. And then the y direction, square root of 9 is 3, so up 3 and down 3. And then we'll use those 4 coordinates to get our vertices, which will be the major axis is along the x-axis. So that's going to be 7, -3, and -1, -3, I think. And then the co-vertices is going to be 3, 0, and 3, -6. Okay, so that takes care of the center point, the vertices. Last thing is the foci. So if we want to find C squared, A squared minus B squared will be 16 minus 9, which will be 7, I think. So that means C is going to be plus or minus the square root of 7. This time we're being stretched in the x direction, so we're going to take our center point and add C to the x term, or the h term rather. So it'll be 3 plus or minus square root of 7, comma, -3. All right, almost there. 8 and 9 look a little bit different. Notice they are not in standard form. We dealt with this with circles yesterday, right? They have all the x's and the y's, or everything is like foiled out, if you will, and written kind of in this polynomial type form. So yesterday when we did circles, we implemented completing the square in order to get this into the form that we need. And we're going to do the same thing for the ellipse, except we're going to complete the square twice, and there's going to be one little difference that we have to be mindful of. Okay, so the first thing that we want to do is group our variables, x's with x's, y's with y's. So I've got 16x squared minus 96x plus, we don't know what c is. That's going to be a new c, plus 25y squared minus 200y plus whatever our new c is going to be equals negative 144. Okay, before we complete the square, do y'all remember from yesterday, what must the coefficients of your x squared and your y squared terms be? They have to be 1. So in order for that to happen, we need to go ahead and factor out their current leading coefficients. So for my group of x's, I'm going to go ahead and factor out 16. And when I do so, that's going to leave me with x squared. 16 goes into 96 6 times, so that'd be x squared minus 6x. Again, I'm going to leave my plus new c spot available. Plus, I'm going to factor out 25 from my y's, leave me with y squared minus 8y plus whatever my new c is equals negative 144. So step 1, rearrange. Step 2, factor out. Make sure you have leading coefficients for x squared and y squared to be 1. And then now we find our new c. So remember, new c's are found by doing b over 2 squared. So you're going to do it twice, okay? For the x's, that's going to be negative 6 over 2 squared, which is negative 3 squared, which is positive 9. For the y's, b over 2 squared will be negative 8 over 2 squared, which is negative 4 squared, which is 16. So here's where things get tricky. You just have to be careful. When you add 9 to your x trinomial, technically you're not just adding 9. What are you adding? Say it again. I heard something.
9 times 16.
Very good, Zach. You're adding 9 times 16 because that 16 distributes inside to everything in those parentheses. Same thing with the y's. When you add 16, you're not just adding 16, right? You're adding 16 times the 25 that's on the outside of that parentheses as well, because it'll distribute in. So this is the tricky part, trying to remember when you add to both sides to remember the distribution of the coefficient on the outside, or the constant on the outside. And then we just need to simplify. So for our x's, we're going to get 16 times. This trinomial can be rewritten as x minus 3 squared plus 25 times the y trinomial can be rewritten as y minus 4 squared. And then you could enter all this stuff on the right-hand side as is. Just be careful about it. You should get 400 when you do that. So we're so close. This is almost to the format that we need it, except it's not. What is one of the big issues with the way that I have this written right now if I'm claiming that this is the equation for an ellipse? It has to equal 1. Okay. So if it has to equal 1, in order to make that happen, I can simply divide the right-hand side by 400, because I know 400 divided by 400 is 1. But whatever you do to one side, you have to do to the entire other side, or everything, if you think about it that way. So I'm going to divide everything by 400. In doing so, what's going to happen is you actually need to simplify these fractions out front. 16 over 400 and 25 over 400. And in doing so, you're going to get x minus 3 squared over 25 plus y minus 4 squared over 16 equals, and then 400 divided by 400 is 1. So all of that hot mess was to just get us back to a normal standard equation for an ellipse. And then once you get here, you need the rest, the center, the vertices, and the foci. So let's go find that now. The center point is our h and our k. So we switch our signs where the x's and the y's are. So it's going to be positive 3, positive 4. So the right 3, up 4. The vertices are going to come from our a and our b. So if 25 is a squared and 16 is b squared, that means in the x direction, the square root of 25 is 5. So in the x direction, I'm going to move 5 to the right and 5 to the left. Shoot, sorry, I'm off the grid again on this one. And in the y direction, I'm going to go up 4 and down 4 from the center point. And then graph that. And it's hard to tell because it's only off by 1, but the main axis, the major axis, is going to be in the x direction because 25 is bigger. So those vertices are going to be 8, 4, and negative 2, 4. 8, 4, negative 2, 4. Co-vertices are going to be the shorter ones. That'll be 3, 8, and 3, 0. So this is the center, those are the vertices. For the foci, I need c. Well, if c squared is equal to a squared minus b squared, we already know a squared is 25, b squared is 16. So it'll be 25 minus 16, which is 9, which must mean that c will equal plus or minus the square root of 9, which is 3. And we are adding that in the x direction. So the foci will be 3 plus or minus 3, comma 4. And all of this is the additional information. And then see, these foci are nice. That's going to be 3 plus 3 is 6, comma 4. So these are actually are on coordinates. They don't have any radicals. And then 3 minus 3 is 0, up 4. So those are the foci for those. Okay, one last one. Chugging right along. If we finish this today, that means you have all of tomorrow's class to work on the homework, rather than me taking up your time to finish it. So just chug through and get the last one done and call it a day. Okay, similar scenario as we did in the last problem. We're basically following the same exact steps. So the issue is I don't have my equation of the ellipse in standard form. So we got to get it there. So first we want to go ahead and group our variables. X's with X's, Y's with Y's. So we got 3x squared plus 18x why does it do this? Sorry, some technological issues here. Okay, let me try again. 3x squared plus 18x plus we don't know what our new c is going to be. I don't know if y'all can see it. When people watch the video, they're definitely going to see it. Every time I write something, it's automatically erased. I don't know why. Let me try. That's all I need is to make this video longer. Awesome. I am so close. Y'all can go ahead and try to keep solving this without me. Oh, maybe it's working now. Okay, 3x squared plus 18x plus whatever the new c is going to be. Plus y squared minus 2y plus whatever the new c is going to be is equal to the constant will be negative 4. Now, before we find our new c, we need to make sure we have leading coefficients of 1. We don't have that for the x's, so I've got to factor out my 3, leaving me with x squared plus 6x plus whatever that new c is. And then our y squared terms are fine. There was nothing to factor out there because we already had the y squared leading coefficient of 1. So it's at this point we can go ahead and find our new c's. So for the x's, it'll be 6 over 2 squared, which will be 3 squared, which is 9. For the y's, it'll be negative 2 over 2 squared, which will be negative 1 squared, which is 1. So remember, this is the main difference between this and circles. When I add 9 here, I'm technically not just adding 9. There's a 3 being distributed on the outside. So to the right-hand side, I need to add 9 times 3. Now, when I add 1 to the y's, there's no number on the outside of that trinomial that's being distributed in. So that one really is just legit adding 1. So then all of this is what you're going to be adding on the right-hand side. So if I rewrite these trinomials, I'm going to get 3 times x plus 3 squared, plus my y's can be rewritten as y minus 1 squared, equals, let's see, negative 4 plus 28 will be 24, I believe. And then again, if this is going to be the equation of an ellipse, it has to equal 1. So I need to go ahead and divide everything by 24. In doing so, 3 over 24 will reduce to 1/8. So I'm going to get x plus 3 squared over 8 plus, there is no coefficient for this y minus 1 squared, so that one's just going to stay over 24. And then that's going to equal 24 over 24 is 1. So all of that was to get our new standard equation. And then from here, we can go ahead and get our information to be able to graph it. Center point's the easiest. HK is going to be the opposite values of what is written. Now, technically, I could rewrite this. Why? What's the issue with what I've just circled down here as my standard equation? Yeah, A is smaller than B. So ideally, what we want to do is switch both terms altogether. You don't want to switch. You don't want to move just 8 and 24. You'd have to move the entire fractions. Okay, but we can still get our information accordingly, as long as you remember that A squared is your bigger term and B squared is the smaller one. Okay, so the center point is going to be at negative 3, 1. And then here's where the vertices are going to be a little bit challenging because we're not just going to be able to graph them. Let's do the major ones first over the vertices. A squared is 24, which means if A squared is 24, then that means A is going to be the square root of 24 plus or minus the square root of 24, which we did earlier. If that can be written as the square root of 4 times the square root of 6, then that means A is plus or minus 2 square roots of 6. Okay, so you can either kind of logic your way through this, or if you refer back to the front page and actually do the, I'll say, equations to find we got a vertical orientation, right? Because we have a larger y-axis. So for the major axis vertices, we're going to be doing h, comma, k plus or minus a. So it'll be h, k plus or minus a. Well, we already know what h and k are, and now we just found a, which means our vertices can be written as negative 3, 1 plus or minus 2 square roots of 6. The co-vertices are going to be similar, except that we're going to be adding b to the x-coordinate. So if you use that formula, that's going to be h plus or minus b, comma, k. Well, if b squared is 8, then that means b is going to be plus or minus the square root of 8. which the square root of 8 could be rewritten as the square root of 4 times the square root of 2, which is plus or minus 2 square roots of 2. So that means the covertices can be written as -3 plus or minus 2 square roots of 2, because that's b, and then k is still 1. So this is a little bit more challenging because these coordinate points are not on the actual grid. They don't snap to it. So to actually graph it, you're just going to have to be creative and estimate. So from that center point, that's going to be, I think 2 square roots of 6 is going to be like 4 point something. Can someone estimate for me what is 2 square roots of 6 as a decimal? Say again, Zach, I'm sorry, 4.9? Okay, so it means from the center point, we're going to go up almost 5 and down almost 5. And then 2 square roots of 2 is going to be like 2 point something. I know that. So we can just go a little bit over 2 to the right and over 2 to the left to estimate that. And then the last thing we have to do is the foci. In order to find the foci, c squared is equal to a squared minus b squared, which means that c squared is going to be, we already said a squared is 24, b squared is 8, 24 minus 8 is 16, which means c is just plus or minus 4. Now, it's vertically stretched in the y direction, so that means the foci is going to be our center point, -3, and then to the y value 1, we're going to add plus and minus 4.